students, let us begin with the next content of the chapter Motion in a Straight Line. So in the previous lecture we have learned about one new term related with it, that is speed, and today we are going to study further information related with speed. So we have defined the term speed as it is nothing but distance upon a time taken, means in a particular given time what is the distance covered. When we take into consideration these two things, we have defined the new term that is nothing but speed. So today we are going to study two terms, that is first is known as uniform speed and the other is known as variable speed. So uniform speed, it is a type of speed wherein the object will cover equal distances in equal duration of time. Means when we begin the journey, when we start calculating what is the distance covered by the object, and if the object will cover same interval of distance in that given time, then that speed is termed as what? Uniform speed. So I have plotted a table here wherein I have noted down what is the time and the distance. So when we come across for uniform, okay, let us take these values. This is the time. Time is being measured in terms of second. Let T is the notation for representing time. So when I start my stopwatch, the stopwatch will give you 0 as the reading. And at the duration, the distance covered by the object may be 0. So as the time changes from 0, 1, 2, 3, 4 and so on seconds, the time or distance covered by the object will also vary. So let us consider that the object will cover equal distances in equal duration of time. That is from 0 to 1, the time taken is 1 second here, and the distance covered between these, it is equivalent to 5 meter. So the next time interval from 1 to 2, that is again equivalent to 1 second. The distance covered is from 5 to 10, that is also equivalent to what? 5 meter. Further, if you go for 1 second variation, the distance covered by the object will be also remain same, that is 5 meters in that 1 second interval. Okay. So when this happens, the speed attained by the object is said to be as uniform speed. It is called as what? Uniform speed. So it is defined as, it is nothing but the object will cover equal distance in equal interval of time. So both the distance and time intervals are same. They remain constant throughout the journey of that object. But when we move regularly along the road, sometimes we need to apply the brake, the speed will get reduced down. Okay, when no one is there, when we are moving in a highway, we will go with higher speed. In that case, our speed will increases. Okay, it will go reach higher values. In certain cases, it may come down. So, the speed attained by the object will not remain same. In that case, we will define another term that is known as what? Non-uniform speed, or it is also called as variable speed. So, variable speed or non-uniform speed will be defined in such a manner that if the object will cover unequal distances, unequal means it is not the same throughout, unequal distances in equal interval of time. So, time interval will remain equal. So, I have again noted down the values roughly over here. So, the time duration is changing by equal magnitude. It is said to be as equal variation of time. So, 1 second time. But which quantity is not equal here? It is not remaining same. The distance. So, distance in the first 1 second it is covering 5 meter of distance. In the next, it is covering distance of just 2 meter. Then it is covering a distance of how many? 5 meter. Further, it is changing the distance to be equivalent to 5 meters. So let us take this as 80. So let this is increasing the speed. Let it be equivalent to 6 meter of variation. So here, when we check these values, it is 5, 2, 5, 6. Okay, the distance is covered, it is not the same. So in a such a manner, when the distance is not equal throughout the motion of the object, okay, the speed attained by the object is said to be as non-uniform or variable. Variable is nothing but something which is changing continuously. It is not remaining constant. Then that type of speed is termed as what? Variable speed. So if we plot the graph of these two quantities, okay, plotting it requires a plane. So we have a plane over which we are taking two coordinates. One is x along and the other is along the y. And along the x axis I have taken the variable time, which has been measured in terms of second. Along the y axis I have taken distance as the variable, which has been measured in terms of what? Meter. So the time here it is changing from 0, 1, 2, 3 and so on. Therefore I have taken the intervals as 0, 1, 2, 3, 4 and so on seconds. Whereas the time, the distance which is there, it is been written as 5, 10, 15, 20. So for 1 centimeter, the magnitude of the distance I have taken is how much? 5 meter. So when I plot the graph for these two values, that is for uniform speed, for 0, the distance covered is 0. So the first point I get over here. Then for next 1 second, it will go and cover a distance of 5 meter. For 2, it is 10. So 10 will come over here. Then for 3, it is 15. And for 4, it is 20. So when I join these all, I am getting a straight line. Okay. So whenever you are traveling with uniform speed, the nature of graph is always a straight line. It is always a straight line. Is the point clear? Then, when we plot a graph for non-uniform speed, wherein the speed of the object is not remaining constant. Okay. In that case, if you see the plotting, so the time is 0, 1, 2, 3, 4 as so on. Similarly, I have drawn here. And speed, it is changing. So for 0th time interval, it is 0. So where the 0 will come here. Then for first, it will cover a distance of 5 meter. The next one more second, it will cover a distance of how much? 7. So it is 5. If I divide it into 5 equal intervals, 6, 7, 8, 9, 10. So this is my 7. So when I plot the 7th point, I get over here. Similarly, for third second, it will cover a distance of 12. So this is 10, 11, 12, roughly over here. And for fourth second, it will cover a distance of 18. So this is 20 nearby here. I'll get the next one. So when I join it, instead of getting a straight line, what I'm getting? I'm getting a curve. I'm getting what? A curve. So whenever the nature of graph is curvilinear, we will attain the variable value for the speed. We will attain what? Variable value for the speed. Now if we just want to calculate the readings from the graph, okay, uniform speed, it is a speed. So it is nothing but a ratio of distance covered divided by time. So directly from this graph I will get the time. So if you want to measure what is the distance covered by the object from 2 second to 4, so if this is a 4, I need to draw a triangle in this manner. So this distance, how much is the distance? 20 minus 10. So 20 minus 10 is the distance, and what is the time? 4 minus 2. So in this case, the speed of the object is equivalent to how much? 10 by 2, it is equivalent to 5 meter per second. So this is the case for uniform speed. And if you go with what? Variable or non-variable speed, it is difficult to measure the reading because from 3 to 2, the nature is curved like this, isn't it? And in that case, it is difficult to measure the value for what is variable speed. So in that case, whenever the speed is variable, we will find its average speed. What we will find out? Average speed of the given object. So it has been defined as ratio of total distance. It is defined as ratio of total distance covered by the object divided by the total time taken. So mathematically it is given as total distance upon total time taken. Okay, and it is denoted by the symbol delta whenever we are measuring the values. Okay, graphically it is represented by delta of d. D is the distance. So total distance upon total time taken. That will give you the value for variable speed, and it has been denoted as what? V average. That is average speed. It is called as what? Average speed. Okay. So we have studied just now about speed and its types. So along with that speed, we have one more important variable in this chapter, that is velocity. So velocity, it is nothing but the ratio of displacement upon time. So when we talk about speed, we will take into consideration the distance traveled by the object. But when we talk about velocity, we will take into consideration the displacement made by the object. So displacement, we know it is nothing but the shortest distance between 2 points, that is initial and final points. So when we take into consideration distance covered by the object, then V, it is speed, and when it is a displacement, it is nothing but what? Velocity. So velocity, it is defined in this manner. It is a rate of change of what? Displacement. Rate of what? Change of a displacement along a given time. So here, instead of writing the definition as a ratio of displacement upon time, I have used the word rate of change. Means how fast the object is changing its displacement. So this term, when it comes, it is nothing but I am taking the ratio of time with a given quantity. So here the given quantity is a displacement. So displacement upon time. Okay, instead of using this word, we can also use the term as rate of change. Rate of change, how fast, okay, with respect to time. So with respect to time, which quantity is changing here? Displacement of the object. Now displacement is a vector quantity. Vector quantity is something which has a direction also along with what? Magnitude. Okay, so therefore along a given direction, okay, then that quantity is called as what? Velocity. So velocity, once again, we will define in this manner like this. It is a rate of change of what? Displacement of the given object along a given direction. So if the object changes its direction, the value will vary. Okay, therefore we need to take into consideration the direction of the object also. So when I represent the term velocity by variable v, I have written one new notation here. That is above v, I have written one arrow mark. So this arrow mark indicates that the velocity is a vector quantity. In your NCERT textbook, they have used the bold dark letters to represent the vector quantity. But when you go with any other type of reference books, okay, we can see representation like this, that is V about arrow mark, or sometimes just V bar. That will give you the vector quantities. Okay, so I will use the notation as V bar here just to represent that velocity is a vector quantity. So velocity is nothing but displacement upon time, and the displacement we have already represented as x. Since the displacement is also a vector quantity, it has to be denoted by a arrow mark above it. Okay, or we can use this x bar to represent that your displacement is a vector quantity. So x bar upon time t will give you the velocity. Velocity, already have told, it is a vector quantity. It has both magnitude and direction, and it is being measured with the unit, SI unit, meter per second. Okay, So the displacement has been measured in meter and time has been measured in seconds. So meter per second is the SI unit for measurement of what? This velocity, and then we have a dimensional quantity. So M represents mass. We do not have any mass variable here. So M0, L is representing distance and displacement is nothing but a type of distance. So L to the power 1 and T to the power minus 1 will give you the dimensional formula for what? Velocity. Then velocity can be positive, its value can be negative, and it can be also equivalent to 0. Since velocity term includes the displacement, and we know that displacement of the object, it can be positive. Obviously your velocity will become positive. If it is negative, the velocity will become negative, and if it is 0, the velocity will be 0, because it is basically depends upon displacement, not on time. Time is always a positive quantity. So if the variable should change, it is displacement. So when displacement is positive, negative, 0, in that same thing your velocity will also become 0, positive, negative. Then one more point related with it is velocity is always equal to or less than speed. It is equal to or less than speed, because here see your velocity may be 0 but speed won't be 0, because your distance is not equivalent to 0. Therefore, it is always less than speed, and sometimes it is equivalent to speed when the object is moving in a straight line without changing the direction. In that case, the velocity of the object will be equivalent to speed of the object. So, velocity is either less than or is equivalent to speed. Then, we will see its types. Similar to your speed, we have seen there uniform and non-uniform speed. Here also we are defining the similar type of terms. First is known as uniform velocity. So what is meant by uniform velocity? So uniform velocity is the velocity of the object when the object is moving along a straight line. Why the term straight line is being represented here especially? Because the object should not change its direction when it is moving. So when it changes its direction, the quantity will vary. Therefore, the consideration is it should move along the straight line, and then it should cover equal displacement in equal interval of time. So when the object is moving along a straight line covering equal displacement in equal time, then that physical quantity is called as uniform velocity. In the other manner, if the object is not moving with similar displacement, or sometimes with the time, or it is changing its direction, then that physical quantity is called as variable velocity, or sometimes it is called as what? Non-uniform velocity. So it has been defined in this manner. If the object is covering, I have told you there are different cases in it. So I have represented those cases. First is if it is covering equal displacement. So the displacement of the object is not changing. It is covering equal displacement. But the quantity here which is varying is what? Time. So time is not same. So unequal time. In that case, the velocity of the object is said to be as variable. The second case is if the object is covering unequal distance. So which quantity now it is not equal? It is the displacement. So if the displacement is not remaining constant throughout the motion, even the time is constant, time variation is not changing, it is remaining equal. So that also called as what? Variable velocity. And the third is, as it is a vector quantity, we have to take into consideration the magnitude along with the direction. So if the object is changing its direction, then also the velocity will be variable. So if it is moving with uniform speed, it's equal distance, displacement in equal time, but which quantity is changing here? Direction of the object is changing. Then that physical quantity is called as what? Variable velocity. Okay. So here directly we will get the value for uniform velocity, but when we go across calculation for variable velocity, it is not easier to measure the value because the displacement is continuously changing. Sometimes the direction is vary. So therefore, to calculate the variable speed, we have defined a new term that is called as average velocity. So average velocity is defined as ratio of. It is defined as what? A ratio of total displacement. What is the total displacement covered by the object in that given total time? In that given interval of time, how much is the displacement covered? So when we take into consideration these two quantities, we have defined the term what? Average velocity. Since it is a vector quantity, again V bar, I have noted it as V, okay, and to the lower power it is average. AVG represents average value. It is equivalent to total displacement upon total time. So total displacement, how do we measure displacement? It is nothing but shortest distance between 2 points, initial and final position. So how do we get that? By taking the difference between these 2 points, initial and final. So initial position is the first one, it's a difference with the final. So difference between these two quantities will give you the total displacement traveled divided by total time. So if the object's initial position is x1, if it shifts to x2, so x2 minus x1 will give you the total displacement, and for that if t1 is the time when it begins at x1 and t2 is the time when it reaches x2, so t2 minus t1 will also give you the total time interval, okay, for that object in motion. So t2 minus t1, so ratio of these two quantities will give you the average value. It is also denoted by delta of x upon delta of t. Okay, so we have studied in this lecture about speed, its types, similar manner velocity and its types. So the main quantities are speed and velocity. Sometimes they'll ask you the difference of speed and velocity. The remaining content of this chapter we'll see in the next lecture.